Welcome, it's Saturday Extra. My name is Tinyiko Kosa and it is now time for physical sciences. Now today we're going to talk about organic chemistry. In other words, we're continuing talking about organic chemistry because we've already started with it. We've done some introduction to it. We talked about alkanes, we talked about alkynes and alkenes. We also looked at the issue of isomerism and isomers, so we've defined those things. But now today the focus of the lesson will be on functional groups, on organic molecules. The question will be, what are functional groups? And therefore we will continue in this lesson and we will be able to give to you or define to you what a functional group is. And in these functional groups we'll be talking about haloalkanes, we'll be talking about ethers, we'll be talking about alcohol, we'll talk about aldehydes, and to proceed, we'll also be talking about what we call ketones. We'll also talk about carboxylic acids. And lastly, we'll be talking about esters. Okay, so those are the organic molecules that we'll be talking about in terms of their functional groups. Now, it is time now for us to try and answer, what do we mean by a functional group? Functional groups are individual atoms. So we can talk individual atoms or groups of atoms or group of atoms. These are attached to carbon chains. So remember the carbon chains we spoke about for organic molecules. So these groups of atoms or individual atoms are attached to carbon chains or carbon rings, okay, of organic molecules, that give the characteristic properties of such molecules. So characteristic properties of such molecules. Okay, so these are the functional groups. This is by and large a definition of what a functional group is. Now we're going to unpack this per type of organic molecules to know exactly what functional group defines a specific chain or a homologous series for an organic molecules. Like we'll be looking at what is the functional group of alkanes, for example. What tells us that this is an alkane from the word go? So let's just proceed. Right, let's look at this table here. The table is on functional groups. And in the middle here, we'll be giving the name of the molecule we're going to use as an example. And up here, the last column will be showing the structure of the functional group. Let's start with the first one. We have the simplest homologous series of organic molecules, the alkanes. Now, let's talk here, say we have methane, or let me just use ethane, okay? Now, if you look at ethane, what will be the structure of ethane? We know that for it to be an alkane, there is a single bond between carbon atoms. So this single bond becomes the functional group. The single bond between these two carbon atoms becomes the functional group of alkanes. Now, let's proceed and look at the rest. If we come to the alkenes, remember that the alkenes are organic molecules with double bonds between carbon atoms. So let's take an example of ethene. Okay, so we have ethene there. Now, between two carbon atoms, there should be a double bond for alkenes. But remember that each and every carbon atom can only make a maximum of 4 bonds. So it means if the 2 bonds have been used already, only 2 more bonds are remaining. So that becomes the functional group for alkenes. Right. Now let's move on. Let's talk about the alkynes. Now alkynes, we now have triple bonds between carbon atoms. And an example here, we can make use of ethine. Right? Ethine has got 2 carbon atoms. Between them, because it's an alkyne, we're going to have 3 bonds. And because both the 2 carbon atoms have already used up their 3 bonds, it means only 1 is remaining for each of them. And that becomes the functional group of the alkynes. Now, let's come to something else we haven't looked at yet, haloalkanes. Now, remember that when we say haloalkane, the word halo comes from halogen. Okay? So the halogens, and we know these are group 7 elements. Okay? So these are chlorine, bromine, iodine, you know, those molecules. So fluorine included as well. Now, if we talk of haloalkane, it means that we've got something from the halogen group plus an alkane. Now, let's use the simplest one, methane, for example. If we have got chloromethane, okay, say we have chloromethane. It's chloromethane. So it's a haloalkane because there is chlorine and there is an alkane, which is methane. Now here it means we would have something that would have carbon there, methane with 1 carbon atom. One of the bonds should be bonded or be attached to a halogen, and we can put a R for radical there, the halogen radical. But perhaps we can also, in trying to be consistent here so that you know, I was hesitant to say HAL there because we have hydrogen. Remember, hydrogen will always be part of the hydrocarbons we're talking about. But then, we can then use just R to say that this is a radical of the halogen. So that R there will be representing what the halogen is going to be. Now, why just put R? We put R because we don't know what that is going to be. Here we just gave an example of chloromethane. It could be bromomethane, it could be iodomethane, it could be fluoromethane. So that R there stands for any other halogen that we're talking about. So the rest of the bonds will be there. Now, to further clarify this, we can put the H there to say that R is for the halogen. It doesn't matter. All I'm trying to say is that that space there should be occupied by an atom from the halogen group. All right. Now, moving on, we come to something called alcohol. Now, alcohol, what makes an alcohol? Now, we can have, for example, let's talk of the simplest alcohol we can get, methanol. So that will be an example there, the name of one. Now, how do we get that methanol? Remember that meth, it's only 1 carbon atom. We know we would have 4 bonds to it. But one of the bonds for it to be an alcohol has to be bonded to the OH group. But the OH group, we no more write it as, let me use this space here, as OH, all right? They penalize you if you write it like that in the exams these days. So what you need to do is to show that there is also a bond between oxygen and hydrogen. So you say O-H as well. So that OH is the functional group of alcohols. So when we have it like that, we have an alcohol. But then simply without writing a lot there, simply we would say that if we have this OH there, then we have our alcohol. It could be methanol, it could be ethanol, it could be propanol, it could be butanol, pentanol, hexanol, whatever. All these alcohols that we can get from organic molecules. But then once we have that OH group, this tells us that we're talking alcohols. All right. Now, when we come to the next one, we call this an ether. Now, an ether, it's something that will contain oxygen somewhere in the bonds. Okay, that's an ether. And this oxygen has to be between carbon atoms. Now, between carbon atoms, it would mean that if we've got the simplest organic molecule like methane, we cannot have an ether of methane because we can't have oxygen locked up in 2 carbon atoms. But from ethane downwards, we can have ethers of those molecules. Why? Because we have at least 2 carbon atoms and we can separate them by an oxygen atom between them. For example, if we have, say, what we call dimethyl ether. Okay, so let me just give you an example. Dimethyl ether. Dimethyl ether. What will this mean? It means that you have got a radical this side of the CH3. You have got an oxygen bond there. You have got another radical there, and I will put an R prime for it. Now, these radicals just stand for the methyl, the methyl or the propyl or the butyl groups. These are groups that are attached to this carbon atom, to this oxygen atom. Remember, this R here, this radical here would have a carbon atom, and that radical there would have a carbon atom. And if we have it like that, then we have got a functional group of an ether. Okay. Aldehyde. Okay. What are aldehydes? Okay, aldehydes, we've got, for example, let's think of the simplest one. Methanol. Okay. An aldehyde, it's simply an organic molecule where you have a carbonyl group attached to at least 1 hydrogen atom. And what are carbonyl group? A carbonyl group is a carbon double bonded to oxygen. And we can have this here. We can have that this bond to some hydrogen, and this can be to anything. And this will be the functional group for an aldehyde. Okay? Now, it is very important to understand this. First, you have a carbonyl group. What is a carbonyl group? A carbonyl group is the carbon atom double bonded to an oxygen atom. That gives you the carbonyl group. And at least one of the other 2 bonds of carbon should be a bond to hydrogen. And the other one, we don't care what is there. And therefore, here we have an aldehyde. That will be the functional group. And we will, as we proceed, of course, talk about the structural formula of methanol, and we're going to see or have a look at that as we move on. Well, now, coming to ketones, what are ketones? Ketones would also have a carbonyl group. the difference is that with ketones, the carbonyl group, remember the carbonyl group is carbon and double bonds to oxygen. This carbonyl group is bonded, the carbon there is bonded to other two carbons. So you have a situation where you've got this. Let's start here. You have got your carbonyl group, double bond to oxygen, and you have this carbon bonded to another carbon, bonded to another carbon. So you've got that as the functional group for ketones. So this carbon here is bonded to other two carbons. Now you would see here that if we say that that central carbon from the carbonyl group is bonded to other two carbons, it means we cannot have a ketone of ethane, we can't have a ketone of methane. Why? Because we've got one carbon atom for methane, two carbon atoms for ethane. Now, in that way, we cannot have one carbon atom bonded to other two carbon atoms. So that tells you that our simplest ketone we can have is a propanone. All right, and we are going to talk more, of course, of this naming. Don't worry about them for now. We'll talk about how do we name this. So propanone will be our simplest ketone. So that becomes the functional group of ketones. The next one on the row is what we call carboxylic acids. Now, carboxylic acids, here we have got a carbonyl group again. But look at what happens here. Carbonyl group. So there is the carbonyl group bonded to something there. Here it is bonded to oxygen, bonded to hydrogen. Is the COOH kind of a functional group for carboxylic acids. All right? And then what example can we talk about? We can talk about, say, the simplest one, methanoic acid. Now we will talk more about how to name this. Don't worry about it for now. There will be a section where we talk about naming them. Now lastly, let's talk about esters. Now what is the functional group of the esters? Again, we have esters having a carbonyl group. Now look carefully how the carbonyl group works for esters. We have the carbonyl group, so C double bond to oxygen, bond to another oxygen, and a bond there, nothing attached, no hydrogen attached to that. And we can have something, of course, bonded to that side there. But then any example of what an ester would be, I'll give you an example. Say we have what we call methyl ethanoate. We will talk about how this name came about. Methyl ethanoate will be an example of an ester. Okay, so that is an example of an ester, methyl ethanoate. Don't worry about the name now. Like I've been saying, we'll be talking more about this as the lesson proceeds. Moving on, let's start now to unpack alcohols. Now, I'm not going to go back and talking about the alkanes, alkenes, and alkynes in details because that has been done already. So I'm coming to alcohols and we'll be unpacking every other thing else except for alkanes, alkenes, and alkynes because that has been done already. Now, when we talk alcohols, we see that for alcohols, one of the hydrogen, of course, from the alkanes, one of the hydrogen from the alkanes is replaced or substituted by the OH group. For example, if I've got methanol, so I've got that, I've got methane like that. One of the hydrogen atoms, okay, one of the hydrogen atoms, say this one, is replaced by an OH group. So you've got O there and the H there. And that gives you your alcohol. And what alcohol will be this? This will be what we call methanol. So all alcohols, we name them by putting all at the end. You see it was methane, now it is methanol. We have removed the E and put the OL, methanol, to make it an alcohol because of that OH group over there. So that becomes methanol. Well, now reaction with oxygen. If alcohols react with oxygen, this is what happens. If we have an alcohol reacting with oxygen, generally this is the formula. We would have carbon dioxide formed. So it's carbon dioxide and water. This is what is going to be formed. We will look into details about these chemical equations later on in the next lesson. But then generally you must know that when an alcohol burns in oxygen, just like any other hydrocarbon, carbon dioxide is formed and water is formed. Now, how do we name alcohols? Now, I have explained that with alcohols, the first thing that we need to know whilst naming them is that at the end, we've got a suffix that we need to use. It's all. So if it's an alcohol of methane, it means that will be methanol. Propane will be propanol. Okay? Butane will be butanol. So this is generally how we name them. But we need to go further in explaining this because there is also the IUPAC way of naming them. Right, let's move on to talk about primary, secondary, and tertiary alcohols. Now we'll also be making use of the IUPAC system to name these alcohols so that we can know what they are. Now let me make use of pentanol, for example. We will have 5 carbon atoms because it's pent, and if I have all these bonds here around carbon atoms from my left with hydrogen atoms around them like that, okay, and I have on this last carbon atom I have the OH bond there, the OH group there. Here I've got an alcohol, this is pentanol. Okay, we know it will be pentanol. Now, let's make use of the IUPAC naming system to get the correct name for this molecule. You know that with IUPAC naming, we need to number the carbon atoms, and we'll number them from the one closest to the OH group. So that becomes number 1. It can't be the one on my far left. It has to be the one on the far right. So that is carbon number 1, 2, 3, 4, 5. Okay, and because it's 5, it's pentanol. Now, here, we see that the OH bond is attached to carbon number 1. So to be precise in terms of IUPAC naming, this will be pentan 1 all, meaning that the carbon atom attached to the OH group is carbon number 1. All right. Now, and we will call this primary alcohol. Why is it primary? It is primary alcohol because the carbon, which is this one, the carbon which is bonded to the OH group, is only bonded to one other carbon. The rest or the other atoms are only hydrogen in that way. So that is how we get to know it as a primary alcohol. Now, if we were to move on and begin to talk about secondary alcohol, how will a secondary alcohol differ from the primary alcohol? Say, for example, we have our pentanol in this way. So I still have my 5 carbon atoms, and I have my OH bond here, okay? And then I have my hydrogens there in that way, all right? So there are my hydrogen atoms around the carbon atoms. We're still talking pentanol. But when we apply the IUPAC naming system, we see that the OH bond is on that carbon atom there. And because in terms of numbering, we need to number our carbon atoms from the one closest to where that functional group is. We will start there. And that becomes the least number. So that's 1, 2, 3, 4, 5. If I started from left, this would have been carbon number 4, and therefore that's not least in the chain. Now, this, in IUPAC terms, it will be called pentan 2-ol, saying that the carbon with the OH bond is carbon number 2. Now, again, we will call this a secondary alcohol, okay? Secondary alcohol. Why secondary alcohol? Because the carbon, which is carbon number 2, attached to the OH bond or group, is having 2 carbon atoms attached to it and only 1 hydrogen there. So the fact that it has got 2 carbon atoms attached to it, that makes it a secondary alcohol. The first one, remember, it only had 1 carbon atom, this one here, attached to that, and therefore that made it to be a primary alcohol. So this one with 2 attached to it, 2 carbon atoms, that then becomes a secondary alcohol. Now, can we move on to talk about tertiary alcohol? We can stick to our pentanol, okay, so that we see how it works out. There is my 5 carbon to give me my pent. And now, if I have, for example, a branch here, say a methyl branch. So that's what I have, okay? And I would have my hydrogen atoms there. I would have another one there. And here, that's where I have my OH. That makes my molecule an alcohol. Let's see what happens here. Okay. Now, I need to number my carbon atoms according to, following the IUPAC system. And to do that, I need to make sure that the one giving me the functional group, in this case the OH, must have the least number. If I count from left to right, this is 1, 2, 3. If I count from right to left, it's 1, 2, 3, so it doesn't matter where I count from, okay? But for the sake of order in the way we're doing it, let me choose to count from the left. So 1, 2, 3, 4, 5, okay? And where carbon number 3 is, that's where the OH is, and apart from the OH, I also have a branch here. I think you can identify that branch. So I've got, again, pentanol, okay? But this pentanol has got a methyl with it, okay? So I'm acknowledging the methyl part there. Methyl. Then, where do I have the OH bond? It's on carbon number 3, so it will be pent. It will be pentan. There. Okay, so it will be pentan 3-ol. Okay, methyl pentan 3-ol. And this is a tertiary alcohol. What makes it a tertiary alcohol? It is a tertiary alcohol because the carbon where the OH group is attached to has got 3 carbon atoms bonded to it as well. There is the first carbon atom. There is the first, here is the first carbon atom bonded to our carbon with the OH group. There is the second one, and there is the third one. And because it has got 3 of the carbons around it, it then becomes what we call a tertiary alcohol. Right now, the full IUPAC name for this molecule, because you would remember we also have the methyl there. We also have to show, although it is not a functional group here, we also have to show at which carbon atom along the longest chain is it attached. And therefore, for the full IUPAC name here, we will then have this as 3-methyl, it would be a hyphen there, 3-methyl pentan 3-ol. So you are also mentioning where the methyl group is. It is on carbon number 3. Now, let's look at an example. Example 1. In this example here, what we are going to do, we are going to give the IUPAC names for the above molecules, and secondly, we are going to write down a balanced chemical equation showing how methanol bends in oxygen. Okay, so this time we're going to show an equation. Now let's have a look at this. The first part is we need to give the IUPAC name. Now let's look at this. Here is an alcohol. What makes it an alcohol? The OH group. We need to name it. The first thing we need to check is the chain that we have, the longest chain of carbon atoms. You would see that is what we have. How many carbon atoms are there? We have got 3 carbon atoms. Okay, so that gives us a clue on how to name it. Because we've got 3 carbon atoms, we're talking prop. Okay, so it's going to be propanol because it's an alcohol. But then we need to specify exactly where the OH group is. And how do we do that? We number our carbon atoms from the one closest to the carbon with the OH group. Now, if I start from the left, this is 1, 2. If I start from the right, this is 1, 2. So it doesn't matter where I start. Just to show you what I'm talking about, let's say this is carbon number 1. If I start from the left, that becomes carbon number 2. That becomes carbon number 3. If I start from the right, this is carbon number 1. This is carbon number 2. That's carbon number 3. So it doesn't matter where I start. Every time the carbon number 2 becomes the one with the OH group. So it means that this will be what we call propan 2-ol. These two tells us that the OH group is on carbon number 2 on our propane chain. Right. So we have given the IUPAC name here. Okay? The IUPAC name. That's the IUPAC name. Okay. The next one is this one. We also have to give the IUPAC name, okay, of this molecule. Now let's look at it carefully. This one has got an OH group there. That's an OH group. That's an OH group. How many OH groups are we having here? 3, and therefore this is a tertiary alcohol. But then in naming it, remember, we check the longest chain. It's again 3 carbon atoms, so it's propanol. So this is propanol. Okay. Now, all of them, all the 3 carbon atoms are attached to the OH group. So it doesn't matter whether I number it or not. What I need to know is that I need to mention that 1, 2, 3, all of them have got the OH group. So what I'm going to do is to say this will then be propan 1, 2, 3 triol. Why triol? Because it's 3 of them. There is OH group number 1, number 2, number 3. So the tri means that you've got 3 OH groups attached to the carbon atoms that you have mentioned there, 1, 2, 3. Remember that you need to write it. I need to go back to this because you need to know, you mustn't lose marks here. This in the exam carries lots of marks. You need to get to write everything in details and as clearly as possible. So let me rewrite this in big letters. Propan, I've got a dash there, 1 carbon number 1, comma, carbon number 2, comma, carbon number 3, dash, triol. So propan 1, 2, 3 triol, because there are 3 OH groups that are there. If there were 2, we were going to be specifying maybe 1 and 2 or 1, 3 diol. So the tri for the number of OH groups that are there. Okay? What else did we have to do there? That is what we had to do. We had to give the IUPAC names of all these molecules or the 2 molecules above. So rewriting that, okay, rewriting that, let me rewrite that. The first one was propan 2-ol. Okay, so the first one, let me call it A, was propan 2-ol. The second one was propan 1, 2, 3 triol. Okay, so those are the IUPAC names. The next part, we're going to look at or show how methanol burns in oxygen. Okay, now we're writing this equation. It says we have got methanol, so methanol we know it's CH3OH. It is reacting with oxygen, O2. We know that when alcohols burn in oxygen, what they produce is carbon dioxide and water. So we got the equation right. The second part of the question is that we need to balance this chemical equation. So how do we balance that? Okay, we can see here on the left we've got H3H, we've got 4 hydrogens, we have got only 2 there. Okay, so, but we can't make that just 2, just 4, because we've got oxygen to deal with as well. Okay, so what we're going to do is to make this side to be 8, so we're going to 8 hydrogen atoms, so we're going to put a 2 there to make it 8. 2 times 3, 6, plus 2 is 8. By doing so, we will have to put 4 there, so we've got 4 times 2, it's 8 hydrogens as well on the right. But then by putting this 4 here, we're making oxygen on the right to be 4 times 1 there is 4, and then this is now 6. But this side, we've got 2 oxygens, 4 oxygens. So we also have to do something here. But remember, also the C. These 2 also affect the C, the carbon. So 2 C's now, we also have to put a 2 there. So 2 carbons, fine. Oxygen will be 2 times 2, 4. 4 times 1, it's 4. So 4 plus 4 is 8. Let's see if we have got 8. 2 times that, it's 2. plus 2 gives us 4. So for us to make it 8, what are we going to do? If we have a 2 here, this must have a 3, so that we've got 3 times 2, 6 plus 2, it's 8. So in that way, our chemical equation is balanced. Okay, what is key here is that you need to know that when an alcohol burns in oxygen, which is actually the case with most hydrocarbons, when they burn in oxygen, they produce carbon dioxide and water. You can think of octane, for example, the petrol that we use in our cars. It burns inside the engine. What comes out? It's carbon dioxide and water. Some people would come to the back of the car and check what comes out of the exhaust. Sometimes you see those droplets of water coming out. That is actually the product that we're talking about here, the water. Okay? And also the gas that is coming out with it, which is carbon dioxide. Right. Let's move on. Let's now talk about ethers. Okay? With ethers, what we have is we've got an oxygen between any 2 carbon atoms in a chain. And the general formula or the functional group is that, like we said earlier on. Then the question is, how do we name ethers? With ethers, what we do is we talk of the methyl groups. Okay, whatever was like methane becomes methyl. If it was ethane, it becomes ethyl. So we're talking about methyl group. We're talking about ethyl group. We can talk about propyl group. So these R's are either methyl groups or ethyl groups or propyl groups in that way. So these R's are like that. At the end, you mention the ethyl or the methyl groups, you mention them in alphabetical order. That's how we name them. And we're going to look at an example now. Alphabetical order. And then at the end, the suffix is ether. So we'll be talking something, something, ether. That's how we name this. Let's quickly have a look at an example here. Giving the IUPAC names for the following organic molecules. Let's look at it. Because there is an oxygen atom between carbon atoms, it's an ether. But then what is this part here and what is that part here? You will see these are methyl groups. Okay, so this is a methyl and that is a methyl. So this will be dimethyl ether. Okay, that's it. The next one, you look at this one, this part here, you can see 2 carbon atoms, so this is an ethyl group. And this is 1 carbon atom, is the methyl group. Okay? And so how are we going to name this? Remember, we need to look at the alphabet. Now, E and M, which one comes first? E comes first. So this will be ethyl, methyl, ether. Ether because there is the central oxygen atom in that structure. The next one, we're talking aldehydes. Aldehydes would have a carbonyl group with at least 1 hydrogen atom attached to the same carbon atom. And these are formed, or they are products of an oxidation of primary alcohols. We know what primary alcohols are from what we've done earlier on. And when we name this, the suffix, the end part is al. Okay? Right, let's move on to example 3. Example 3 wants us to talk about structural formulae of the following organic molecules, and we're talking about propanol 2.3 dimethyl butanol. Okay, so those are the 2 molecules we need to work on, show structural formulas of. Okay, so propanol, the basic thing is that we know it's 3 carbon atoms prop, okay, or propanol. Okay, so prop, up to there, prop, we've got that 3. Now, propanol would mean that one carbon is attached with a double bond to an oxygen. That's a carbonyl group. And a hydrogen atom like that. And in that case, we've got propanol. Okay? So that is propanol. Using the IUPAC name, you can say that this is one propanol, okay? Because that is where the carbon atom attached to the carbonyl group is. This one here, the first one, okay? So one propanol. So this is propanol. Okay, easy, straightforward. Now, let's look at the second one. Okay, looking at the second one, this is 2.3 dimethyl butanol. So it is, the main structure is that of but, so I must have 4 carbon atoms, all right? And it says on carbon number 2 and on carbon number 3, I've got a methyl. So I can decide to count from the left or from the right, but always my second carbon atom will be the same. So let me just start from the left. So if I start from the left, this is 1, this is 2. So I'll have my methyl group here because it says 2.3 dimethyl. So the first methyl group is on 2. The second one will obviously be on 3. Allow me to have it at the bottom so that I've got space for it. Okay, there is the second methyl. So I've got 2.3 dimethyl. Dimethyl what? Butanol. Butanol would mean that, remember, the null here, the null there, which is the aldehyde functional group, should be first, or should be considered first in our naming. So I can't have it on carbon number 4 there, then it is not 2.3 dimethyl butanol. So I'll have it here, so double bond here to oxygen, okay, on carbon number 1, and then I'll have my hydrogen there, okay, and the rest will be what? Hydrogen atoms around my carbon atoms like that. Right, so going on having my hydrogens, let me check and be sure I have all of them here. I've got hydrogen there, hydrogen, hydrogen, hydrogen. I have this, the 4 bonds are there, but on carbon number 2, I still have a hydrogen to put there, and in that way, I have all the bonds covered, and therefore this gives us our 2.3 dimethyl butanol. Okay, so that's it. Right, now let's move on to ketones. That's our next functional group. Ketones, okay. Ketones, these are organic molecules with a carbonyl group as well. But this time, this carbonyl group is bonded to 2 carbon atoms. In other words, you've got something like this. You've got a carbon atom there, bonded to a carbon atom there, bonded to a carbon atom there, and here you've got a carbonyl group. So you've got a carbonyl group, they bonded to 2 other carbon atoms, and that then gives you your ketone, okay, in that way. And these ketones are formed when there is a reaction between secondary alcohols with oxygen. So it's the oxidation of secondary alcohols, all right? Remember what secondary alcohols are? Secondary alcohols where you have got your OH bond with, bonded to a carbon atom to which the other, or this carbon atom is again bonded to other 2 carbon atoms. So that's where you have got your secondary alcohol. Let me just show it to you here again. You've got a carbon there, okay? You've got a carbon there, you have a carbon there, and then here, that's where you have got your OH, and I need to consistently show this OH group or this OH bond as a bond between oxygen and hydrogen. So it's like that. So when this OH is bonded to a carbon, which is in turn bonded to other two carbon atoms, then you've got a secondary alcohol. Now, when these kind of molecules react with oxygen, okay, with oxygen O2, and if you like, because we want to keep the system the same here, you can say that oxygen molecule is actually an oxygen bonded to another oxygen like that. When this happens, we form ketones, all right? And then we will also have to be able to work on how do we name ketones, all right? So ketones are named in a simple way. For example, if you have got a ketone of, okay, from propane and into a ketone, or propanol to a ketone, then you would have it as propanone, okay? We will do more examples on this, and you will see how all this come around. So the non at the end, or this one here, tells us that we're talking about a ketone, okay? There are people who sometimes call this propanan. It is not appropriate to call it propanan, because this nan is not the nan as we understand it from the language in English, but it brings in the fact that we're talking about a molecule in organic chemistry called a ketone. So we must be very careful on how you name it. Like you would have butanone, not butanan. All right. So we'll proceed with looking at some of the examples based on ketones. Right. Example 4. On example 4, we are to write down structural formulae of the following: 4.5.5 trimethyl 3-hexanone. It's a long one. Now, the fact that we're talking hex here, now I know I should have 6 carbon atoms forming my longest chain. So I've got 1, 2, 3, 4, 5, 6. Now, this is going to be a ketone, and therefore it must have a double bond, a carbonyl group, which is a carbon bonded to oxygen in double bonds. Now, it says 3-hexanone, so I can choose any here to be number 3. So if I count from the left, 1, 2, 3. So this will be my carbonyl group there, okay? Now, when I have it at 3 there, I'm told at carbon number 4 and carbon number 5, and again on carbon number 5, I've got methyl groups. So if this is my carbon number 1, 2, 3, 4, 5, 6, on carbon number 4, I've got a methyl group. I've got a methyl group. Okay, so I've got that. I've got a methyl group. And on carbon number 5, I've got another methyl group. Again, on carbon number 5, I've got another methyl group. Okay? And therefore, then the rest will be just carbons with hydrogen atoms around them. Okay, so that will be a structural formula of 4.5.5 trimethyl 3-hexane. Why trimethyl? Again, you've got that methyl group there, you've got this methyl group there, you've got that methyl group here. So you've got 3 of them, hence the name trimethyl 3-hexanone. Now, the none at the end there, meaning that it's a ketone, it is actually given by this part here. Okay? A carbonyl bonded to 2 other carbon atoms. Okay? So that's how we deal with that. Let's look at the next one. Structural formula of 3-ethyl 2-pentanone. Okay, pentanone, it means 5. So I must have 5 carbon atoms. On carbon number 2, I will have my none, my carbonyl. So let me put it there. I can put it here, I can put it over there, but this is my second for now. Then I would have, it says 3 ethyl. If this is number 2, then this one would have an ethyl group. It will be number 3. That's ethyl group. The ethyl group. Okay, and therefore that will be hydrogen, 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 hydrogen. Okay. Hydrogen, hydrogen, hydrogen. So that's what we have there. Let's quickly talk about carboxylic acids. Functional group, that COOH group there. That's the functional group for carboxylic acids. Oxidation of corresponding alcohols or aldehyde. Okay, so if you have got methanol and or methanal, because the aldehyde of methanol will be methanal. Okay, now if you oxidize this, you will end up with what we call methanoic acid. Okay, methanoic acid. So carboxylic acids are these organic acids. These carboxylic acids, if you react them with alcohols, they give you an ester. And they are called weak acids. Why? Because they ionize only slightly in solution. So they don't ionize fully. They only ionize slightly in solution. Hence, we call them weak acids. Things like vinegar. Vinegar is an acid. It's a weak acid. Right. Now, let's look at some example. Why are carboxylic acids considered weak acids? Because they ionize only slightly in solution. And perhaps I need to unpack what we mean by ionizing. Formation of ions, the plus and negatively charged atoms or group of atoms in solution. That is ionization. So these ones ionize very slightly in solution. That's why they are called weak acids. Write down structural formulae for the following carboxylic acids. Ethanoic acid. Ethanoic acid, we know, okay, we're going to have 2 for eth, all right? And then remember, ethanoic or carboxylic acids, they've got the carbonyl group bonded to the OH group. And that gives you your acid. And this will be ethanoic acid. Butanoic acid, you've got 4 carbon atoms in this chain, all right? And then there must be a carbonyl group bonded to the OH group to make it an acid, and the rest hydrogen atoms bonded to the carbon atoms. Right, so that gives you your butanoic acid. And lastly, propanoic acid. Propanoic acid, we're talking an acid with 3 carbon atoms. So we've got C, C, C. This one bonded, it's a carbonyl, and also bonded to the OH group. Okay, so bonded to the OH group to make it an acid. Then the rest hydrogen atoms. Okay, so that will be the structural formula of propanoic acid. And now, lastly, let's talk about esters quickly. Now, esters, remember the functional group, it's a carbonyl bonded to oxygen and then bonded to something else. product of an alcohol and carboxylic acids. So if you add these two together, you get esters. How do we name esters? Now, we have got this here. The suffix here, the end part of your name becomes this. Or weight or 8. All right? Now, if we have an ester that has propane, for example, it will be propanoate, okay, and things like that, ethanoate, methanoate. So that is how we name them, and we're going to look quickly on how we follow the IUPAC rules to name this. Okay, example 6. For the following here, we're going to write down the alcohol and the carboxylic acid needed to prepare the ester. Now, after that, we are also going to write down the chemical equation showing how the ester was formed. Okay, so the alcohol that was used here is methanol, and the acid used is ethanoic acid. Okay, ethanoic acid. Ethanoic acid. Okay, ethanoic acid, the OH part there must be the acid part, and the methyl group should be the alcohol part. Now the next part, the next section of answering this question is to show how the methyl ethanoate ester was formed. Okay, so the first thing, let's start with the acid. Okay, ethanoate, 2 carbon atoms, a carbonyl group bonded to the OH. All right, and this carbon atom will have its own hydrogen atoms around it. You add this to methanol. Methanol, it's C. Allow me to have the OH group this side. So H, O, okay, then C, like that. That will be methanol. Okay, and let's see what is going to be produced. What basically happens here is that this part here, this part, either, let's just take it from here, this part here combine to form water, H2O. All right, and then what will be the other thing that will be formed? This remaining part then attaches itself to this structure here, the C, hydrogen, hydrogen, hydrogen. Maybe that is not so clear to you. Let me have the hydrogen there, then C, hydrogen, hydrogen. We have the C there, double bond, okay, and then we have got that. Remember, that whole thing is gone, but this part comes in, this whole part. So this whole part goes in there. So you're going to have O, bond C, then you've got H, H, and H. Now this is your, if you check here, you would see that you've got your methyl group there, okay, and then you've got your acid part there, so that, and you've got the oxygen in between them. So this is now your methyl ethanoate. So that's methyl ethanoate. That's how it was formed. Let's go to the next one. Ethyl propanoate. We have ethyl, the propanoate must be the acid, so we have got ethanol and propanoic acid. Propanoic acid. So how does this work? We're going to have the propanoic acid, three carbon atoms, last one bonded to the OH group to make it an acid. You've got hydrogen, 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 hydrogen there. You add this to ethanol. So again, allow me to have the OH group here. So ethanol, how many carbon atoms? 2 of them. Hydrogen, 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 hydrogen. Now this react, remember this part here, forming the water. So I'll have water there. Let's see if we can squeeze the structure here. So here you've got H, you've got your C, double bond O, and then this structure here coming to attach itself there. Okay, just don't have enough space here, pardon me for that. Then I have got H there, H, 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 H there, and of course this will be plus the water there. Okay, now look at that. This is your, if you continue this part here, we have our hydrogens as well here. So you will see that this part here will be ethyl. This part here is ethyl. So this means ethyl, and this part here has got 3 C's, so it's ethyl propanoate. Okay, that's how it was formed. Okay, and lastly, methyl butanoate, it's methanol plus butanoic acid. Butanoic acid. How does this happen? Let's start with the acid. You've got C, 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 C. It's 4 of them because it's butanoic acid, and then the OH group there to make it an acid. The rest are the hydrogens. Okay, hydrogen atoms around the carbon atoms. So that's what we have. And then we plus that to the alcohol methanol. Again, allow me to have the H here, O, and then C, H, H, H. These then forms. This gives you your H2O, water, plus here, okay, plus what is going to be formed here. We have this part coming there, so you've got C, 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 double bond O, and then you've got this part coming to attach itself there. You've got the O, and then you then have the C, H, H, H. Not enough space here, but that is a C, okay, and the O there, and that's a C. So we have got the H's around the carbon atoms, H's around the carbon atoms like that, and this is methyl, this part here, CH3, methyl butanoate, and that is your that's how your ester was formed. Now that actually concludes our lesson for today. I hope you've enjoyed it. It's time for me to sign off now. My name is Tinyiko. Bye-bye.